Hello everyone, it's lecture 9 to solve polynomial equations of the third degree by Cardan's method. Okay, so if we have any polynomial in third degree, so we have cubed of x plus p1 x squared plus p2 x plus p3 equal to 0. We have here the coefficient of x squared as b1, the coefficient of x is b2, the coefficient of the free term is b3. Okay, so we just will perform this solution by two steps. Okay, so the first step is step 1 of Cardan's method is to make the coefficient of x squared equal to 0. Okay, and what will we do about that? Just we will replace x by y minus p1 by 3. Okay, after that we will obtain another equation of the third degree, y cubed of y plus p y plus q equal to 0. Okay, and we will deal with this equation by Cardan's method. Okay, step 2, to determine the characteristic. Okay, so determine the characteristic d. Okay, just we have here d. Okay, and d equal to, here we have q by 2 squared plus p by 3 and this q. Okay, so and here we have d has three cases. So let's start if d is greater than 0. So our roots are, so roots equal to, here we have I plus k and negative 1/2 I plus k plus or minus square root of 3 by 2 I into I minus k. Okay, and here we have I equal to negative q by 2 plus square root of d and this bracket power 1/3. Okay, and k equal to negative minus square root of d, this is cube root. Okay, and third case, if d, our characteristic, equal to 0, just put here d equal to 0. Okay, and if we put d equal to 0, I here equal to k, so we have here roots equal to, here from the first one 2i, and here we have just I minus k will be equal to 0, so just we have here negative I, and here the third one is negative I, okay? And I here, when we put square root of d equal to 0, this equal to negative half of q, and this is cube root, okay? The third case is d less than 0, so we have here our roots equal to 2 into cube root of r into cosine of theta plus 2 pi k by 3, okay? And here k for the three roots equal to 0, 1, 2, okay? And here we have r equal to, here we have negative p by 3, and this is power 3 by 2, okay? And theta in grams equal to cosine minus 1 of negative q by 2r, okay? Just we will perform our three roots of this equation simply by two steps. So step 1 is to make the coefficient of x squared equal to 0 by putting x equal to y minus p1 by 3, okay? Just obtain this equation, and by determine the characteristic of this equation, which equal to square of half of q plus p by 3, this is cube, okay? D, here the characteristic d might be greater than 0, okay, and might be equal to 0, might be less than 0, okay? Just we obtain our three roots, okay? So let's just remove that and start to take a first example. So example 1, ask to solve cube of x minus 15x squared minus 33x here plus 8 for 7 equal to 0, okay? We will just follow our steps. So here step 1, we must obtain the coefficient of x squared mass equal to 0. So we have here p1 equal to negative 15, p2 equal to negative 33, p3 equal to 847. Okay, we don't have here p1 equal to 0, so just we will perform our transformation of equation by replace x by y minus p1 by 3. So we have here x equal to y plus 15 by 3. We will replace x by y plus 5. Okay, just make that y plus 5 cubed of y plus 5 here, sorry, minus 15 of y plus 5 squared minus 30 y plus 5 plus 8 for 7 equal to 0. We will just expand our brackets here. So we have here y cubed of y plus, here we have 15y squared here plus 75y here plus 125. Okay, this we will multiply negative 15 into this expansion of this bracket. So we have here negative 15 y squared. Here we have minus 150 y, and here we have minus 15 by 25, just multiply. So we have here 33y, here minus 33 into 5 plus 8 or 7 equal to 0. Okay, so we just notice that here plus 15y squared, here we have minus 15y squared. So just we will obtain cubed of y minus 108y here plus 432 equal to 0. Okay, so we just transform this equation of x to this equation of y. Okay, so we have here equation in this form: cubed of y plus py plus q equal to 0. So we have here p equal to negative 108 and q equal to 432. So we will move to step 2 to find the characteristic of this equation. So here we have d equal to square of half of q plus cubed of p by 3. This equal to, here we have q equal to 432 by 2 square. Here we have negative 108. So we have here negative 108 by 3 cubed. Okay, this will be equal to 0. So we have here case 2 of d equal to 0. So just here, just we will clear that and rewrite our equation of y. So we have here cubed of y minus 108 y plus 432 equal to 0, and we obtain that d equal to 0. So both equal to I, negative I, negative I. Okay, just we will write I equal to negative q cube root of negative q by 2. So we have here I equal to negative sorry, negative 432 by 2. Okay, so we obtain here this equal to 216. So we have here negative 6. Okay, so roots will be equal to, here we have negative 12, here negative I equal to 6, here negative I equal to 6. Okay, we just obtain our roots by Cardan's method when d equal to 0. Let's move to another example. The second example asks to solve the equation of cubed of x plus 6x squared plus 3x here plus 18 equal to 0 as we did before. So just step 1, we have here p1 equal to 6, p2 equal to 3, p3 equal to 18. So we just will make b1 equal to 0 in the equation of y. Okay, so here we will just replace x by y minus p1 by 3. So we have here y minus 2. Okay, so we have here y minus 2, this cube plus 6 y minus 2 square plus 3 y minus 2 plus 18 equal to 0. We will just expand our brackets. Here we have cubed of y here minus 6y squared plus 12y minus 8. If we don't know how to expand this bracket, just take a look on our binomial theorem lectures. Okay, so just plus, here we have 6y squared minus 24y plus 24 plus 3y minus 6 plus 18 equal to 0. So here we have negative 6 square, we have here 6 square. Okay, and we will obtain here by simplify this all these terms together, we will obtain here cubed of y minus 9y here plus 28 equal to 0. Okay, this equation in form of cubed of y plus py plus q equal to 0. So we have here p equal to negative 9, q equal to 28. So we will just move to step 2 to determine the characteristic of this equation. So we have here b equal to square of half of q plus, we have here cube root of p by, sorry, cube of p by 3. So we have here, we have here cube equal to 28. So we have here square plus we have here negative 9 by 3, and this cube. This equal to 14, and this equal to negative 3. So we have here 196 minus 27 equal to 169, and here we obtain that d greater than 0, so we will move to the first case of the characteristic. So just remove that and rewrite our equation in y. We know that here we in the first case, so we have here cubed of y minus 9y plus 28 equal to 0. Okay, so here our roots equal to I plus k. Here half of I plus k plus or minus square root of 3 by 2I minus k. Okay, and here we have I equal to cube root of negative q by 2 plus square root of d. Okay, and k equal to cube root of negative q by t square root of d. Okay, we have here negative q by 2, so we have here negative 14 plus t square root of d 169. Okay, yes, we have here 13, so we have here negative 1. Cube root of negative 1 equal to negative 1. Here we have negative 14 minus square root of 169 is equal to 13. Okay, so we have here negative 27. This equal to negative 3. Okay, so our roots equal to I plus k, which equal to negative 1, negative 3. Okay, and here we have I plus k, so we have here negative 1 minus 3 plus or minus 2 I. Here we have I minus k, so we have here negative 1 plus 3. Here we have negative 4, and here we have negative 4, so we have here 2 plus or minus square root of 3 by 2. This equal to 2. Okay, can be eliminated with that. So we have here square root of 3i. Okay, and this is our three roots of this equation. Okay, I hope this is clear, and move to another example. Third example is to solve. Here we have cube x plus 3x squared minus 9x here minus 3 equal to 0. Okay, so here the first step. Okay, step 1, we have here b1 equal to 3, b2 equal to negative 9, b3 equal to negative 3. Okay, so let's transform this equation to another form of third degree equation by both x equal to y minus b1 by 3. Okay, so we have here x equal to y minus 1. Okay, here we have cube of y minus 1 plus 3y minus 1 square minus 9y minus 1 here minus 3 equal to 0. Just expand this bracket. So we have here cube of y. Here we have minus 3y square here plus 3y minus 1 plus 3y square here minus 6y plus 3 minus 9y plus 9 minus 3 equal to 0. So we obtain here cube of y minus 12y plus 8 equal to 0. So we get equation in this form cube of y plus by plus q equal to 0. Step 2, to determine our characteristic. So here d equal to square of half of q plus cube of p by 3, that's equal to, here we have q here equal to 8, so we have here square plus p here equal to negative 12 by 3, that's, that's equal to 4 square here minus cube of 4. This will be less than 0. So we here in the third case of characteristic. Okay, so here just again clear and obtain our roots. So we have here cube of y minus 12y plus 8 equal to 0. Okay, so here our roots equal to 2 cube root of r cosine theta plus 2 pi k by 3. Okay, and here we have k equal to 0, 1, 2, and here we have r equal to negative p by 3. Here we have 3 by 2, and that's equal to negative negative 12 by 3, that's 3 by 2. Then r here equal to, here we have 4 power 3 by 2. So r equal to 8 and theta equal to cosine minus 1. Here we have negative q by 2r. So here this will be cosine minus 1 Here we have q equal to 8. So we have here negative 8 pi 2r. So we have here 16. This equal to cosine minus 1 of negative 1 half. This then theta will be equal to 2/3 of pi. So we have here 2 pi by 3. Okay, just substitute with the values of r and theta to obtain our roots. So we have here roots will be equal to 2, r here equal to 8. So we have here, okay, cosine here we have 2 pi by 3 plus 2 pi k by 3. So just we have here and k equal to 0, 1, 2. Here we have 4. So roots equal to 4 into cosine. Here we have 2 by 9 plus 2 by 3 by k. Okay, and if we put here k equal to 0, this angle will be 2 pi by 9 and so on. Okay, I hope that three cases are clear. Okay, and the conclusion is to solve the polynomial equation of the third degree with Cardan method simply in two steps. Okay, the first step is to make the coefficient of the variable square used in the polynomial equation equal to 0 by substitute with x equal to y minus p1 by 3. Okay, the second step is to determine the characteristic of the third degree equation. Okay, if the characteristic equal to 0, then there are the roots of equation. If characteristic greater than 0, there are here roots of the third degree equation, and here the third case of equation. I hope all of that clear, and thank you.